For a real number x, you have 1 by 2. Log of base 3, 2 to the power of x minus 9 by log of base 3, 4. And another term in terms of log are in arithmetic progression. Then the common difference is what? Remember one thing, x is not the value that has been asked to you. They've asked you what? They've asked you the common difference. Now, looking at this particular thing, I realized that there is a constant term over here. There's a term in log. These things are not matching with each other. There is a division also being given over here. So can I use some of my log identities to ensure that I get better set of values? Let's first try to look at the second value and the third value and try to organize it properly using a identity which we all know, which is log of base AB, and you want to change this to the base of C, then you will get log of base CB divided by log of base CA. Now understand one thing, what they have given you over here is the same base in the numerator and denominator. You can then apply this in the reverse direction and can write it as a single log, and hence the value that I'm writing over here is log base 4 2 to the power of x minus 9 as my second value. Instead of writing it like this, I'm writing it like this. Same identity, apply it on the third term, and you are going to get log base 4 2 to the power of x plus 17 by 2. That's the value that you are going to get. Now, if you look at log of 1 by 2, you have, if you look at the value 1 by 2, every value is present in the form of a log. Let's see if I can get logged and I can get a base of 4 because the other two values are in the base of 4. So can I then simply write this as log of base 4? 4 is what? 2 power 2, right? So that 2 will go in the denominator if I make a 2 present over here. And log base 2 will then become 1. So this is something that you will have to think about in terms of rearranging your values and understand how can you write those better. So these are the three values that I have, which the question is telling me are in arithmetic progression. So the difference of the second term and the first term should be equals to the difference between the third term and the second term. So let me write this. Log base 4 2 to the power of x minus 9 minus of log base 4 2 should turn out to be equals to log base 4 2 to the power of x plus of 17 by 2 minus of log base 4 2 to the power of x minus 9. This is the equation that we are getting. The difference has to be equal. Now, if you evaluate this a little further, you are going to get log base 4 2 to the power of x minus 9 divided by 2. On the right hand side, what are we going to get? Log a minus log b. So that is log of a by b. So you have log base 4 2 to the power of x plus 17 by 2 divided by 2 to the power of x minus of 9. If you look at this equation now, both side log with the same base, I can simply write this as 2 power x minus 9 by 2 to be equals to 2 power x plus 17 by 2 divided by 2 power x minus of 9. If you solve this further, you can simply rewrite this equation as 2 power x minus 9 whole square of that to be equals to 2 times of 2 power x plus 17 by 2. Let's rearrange this equation a little bit more and see if we can get a better set of values for us. So you will have 2 power x whole square of this plus 81 minus of 18 times of 2 power x. This will be my left hand side, right? What will be my right hand side on this? It is 2 times of 2 to the power of x plus of 17. Now understand this thing, you have 2 to the power of x over here, you have 2 power x over here, you have 2 power x over here. It is the same variable term that is moving. Can I take that 2 power x as nothing but, let's say, a? So what will I get over here? I'll get a square plus 81 minus of 18 times of a to be equals to 2 times of a plus of 17. This looks like a simple quadratic equation which we all can solve. A square minus of 20a 81 minus of 17 is what we are looking at. So it is going to be 64. Right? That value should be equals to 0. Now, if you look at this equation, you will realize 16 4s are 64. So this expansion will turn out to be a minus 16 into a minus 4 to be equals to 0. So value of A will be 16 and value of A will be 4. This is what we'll have. Now what was A? 2 power x. So 2 power x is turning out to be 16. That means my value of x should turn out to be 4. That's one value of x. Second, 2 power x turning out to be equals to 4. That means my value of x will be 2. These are the two values that we have. Now remember, we don't have to find out the value of x, we have to find out the value of the common difference. Now if you look at this equation, you were equating the common difference only. So this was your value of common difference that we had gotten down to. Now if you put the value of x as 2 over here, you are going to realize it is going to become 2 power 2, which is 4 minus 9. So a negative input of log is not defined, for which the log is not defined, and hence x equal to 2 must be rejected. So the only value left for us is x equals to 4. Put it back into this equation. Not the equation, but just one part of it. We'll get the common difference. You either put it on the left hand side or you put it on the right hand side. You are going to get the same answer. I'm putting it on the left hand side. Log base 4, 2 power 4, which is going to be 16 minus of 9 divided by 2 is what we are getting. So 16 is 7 by 2. So log base 4, 7 by 2 is turning out to be the answer for this question, which is option A as the answer, log base 4, 7 by 2.